Hello, I'm Norman Snowden, Collinsville, Mississippi, owner of Mykinda Info Software. This is a video in which I discuss analyzing investment and saving account annuities. The video name is Demo2A Analyzing Investment Annuities. The results in the examples are entirely hypothetical. The purpose of the examples is only to show the math that might be used to make similar estimates. The application provides a scheduled summary of the sum of a series of payments at a designated interest rate, including all of the variations such as the number of payments per year, date of payment, interest paid at each payment, and so on. In addition, the future value at any compound interest rate from the present date to a future date is easily obtained. In the special savings schedule, changes can be made to the existing interest rate, payment values, original principal, and the number of payments per year. If a variable interest rate is included in the payments, the average percentage rate can be calculated. The time lapse between two payment dates and the difference in account values between dates can be obtained. For lottery winners, the present value of a future annuity can be calculated. An editor is provided in which extensive discussion of any pertinent information regarding an investment can be written for the record. Thanks for viewing. If you are interested in the program, send an email, duluth@msn.com, subject Saving Demo 2. This video should be available at Vimeo and YouTube. Click on the little hard hat for savings. The first screen comes up and it has rules for program use. Click. We have to agree to abide by the rules for program use. Yes. We click on annuity saving payment. We see we have two records, rent and stone. We covered both of these in the first Demo 1, Saving Demo 1, but we'll recap a little bit of this rent at this time. This home is a $200,000 home, and this person rents it for 10 years. The annual inflation rate is 1.5. We'll use that. The number of payments per year, 12. And the example goes for 10 years, which would be 120 payments. Payment amount, let's check this variable payment. If we took 200,000, we assume that the first rental payment beginning year is $900 per month. But inflation is occurring at the rate of 1.5. So in 10 years, we'll multiply $900 by 1.15. Excuse me. And it comes up $1,035 as the last payment. The number of payments periods is 120. Go home. We'll assume that the saving initiation date is the year 2000, 01/01/2000. And the intermediate payment numbers is 120, the last payment. We click on, well, let's examine this important issue. There are two types of payments. First, payments that you make out of your own pocket. Second, payments that are made for you by others. Example, business rental receipts. For business payments, if the original principal is zero, enter the initial cost of the investment in the orange entry field. The final business account value assumes your payments have been invested in your business account. Check the box if payments are personal, non-business. That's this box here. Let's click calculate and see what the final value would be. It shows that the interest earned would be $41,200.63, and the immediate account value would be $367,300.63. It was compounded 12 times a year, and the compound interest rate is 1.51. The percent gain is 44, and the interest, the gain is 41,200. But the reason this is 51,201 is because we've included a $10,000 enhancement. So the investor profit is $51,201. Let's look at the schedule. We have the payment number, date, payment, principal, and interest, asset value, and account value. Last payment was $1,035 per month. They varied it all the way down. Principal, interest, asset is $10,000. We assume that the reason this asset of $10,000 that during the latter stages of this rental period, a new school was built, which would estimated it would enhance the value of that home property by $10,000. So that adds $10,000 to this principal and interest that was gained. Now, let's take this check away and assume the payments are made by the renter, and we check calculate. Now we see that the percent gain is 89, and the investor profit is $177,301. That's because these payments were made by others. Payments that are made by your personal payments, the only gain you get is interest, because you paid the money to get that interest. Let's look at the asset depreciation on this. The number of periods to depreciate or appreciate is 120. The beginning principal is $200,000. And as I said, we assume that this property was enhanced by a $10,000 increase. And we think that the enhancement occurred during the latter part of the rental period. So the value from the beginning is zero. Excuse me. And then at the end, it's 100% or one value. So we go back home. And we print with a schedule. Now we see this asset is zero to begin with, but it's increasing toward $10,000, and the value, unit value is that. Now we see that the asset value has increased to the full $10,000, and the unit value is 1. Principal and interest is $357,363, but we add $10,000, so it's $367,300.63. We don't don't want a hard copy. Again, if this investor had just put in his $200,000 in compound interest at an interest rate of 1.5% and compounded yearly, 12 times a year, with an assumed begin date of 01/01/2000 and then 01/2010, and we calculate, and we see that $200,000 would have increased to $232,345.08, but only $32,000 in 10 years, but compared to this $177,301. So we see that there's a big advantage in having income from a business that produces payments. Let's go to the special savings schedule. It's already loaded, so we don't have to do anything but just click manage, and there it is. Starting at first payment 2001, and you can see the interest earned to date, the payments amounts, and everything right down the line until you come to the bottom record 2010, and if we calculate that on schedule, you can see the gain as it progresses from the beginning right on down until the gain is $10,000. Now this R and value P is for a regular payment, regular monthly payment. If we if the owner had an expense, say a heat pump that cost $10,000 that he had to pay for, we can add a payment. Click add a payment. Let's add this payment at about 01/01/2008. Or 9/08, and click tab, and we see this comes up 2001, 2001, 2000. Let's change that. I want it to be in the middle of the month, just so we 2008. That's an added payment. This A here stands for added, and we want to remove that. Now it's a regular payment. 2000. 2008. Let's go to the utility and go to the top record. Come down again 2008. And we see that, no, there's still two payments at 1008. At 2008, we need to get rid of one of them. So let's convert that to an A and get rid of it. And now we can delete it. Delete added payment. Go back to check 2008. We still have two payments. Delete added payment. Having a little trouble here. Now we only have one payment on January the 1st, 2008. Now let's add a payment. Like I said, 00101. I'm sorry, 15, 2008. Now we have it in the 15th, the middle of the month. And let's make this payment minus 10,000. Now let's check the value. Calculate. That's 2005, 7, 2008. Here it is on January the 15th, 2008. There's a minus $10,000. See, the interest has to be paid, but that reduces the principal by $10,000, and it will reduce the savings and reduce the amount of interest paid. As the values. That's the last payment. Now, let's assume that we'll make some changes. We're going to change the number of payments per year to, well, we'll have to go back and set the dates. Make changes from 01/01/2000 until 01/01/2006, say. We make changes. Number of payments per year. Let's make it 4 times a year. That would be every 3 months. So 4. Annual interest rate. Let's change that from 1.5 to 6%. In the payment value, let's set that at $950, say. Click continue. It's a message that tells you what changes might occur. We want to continue. We don't want to abandon it. We'll check yes if you want to change the amount between these dates using a different number of payments per year. Check no to keep the payments. Yes, what we want to change, so click yes. Now we have to go back and there was a message there that tells you that you have to repeat that process, the payment value, $9.50, and you have to say that you want to keep that. Click no to yes. We don't want to abandon. We click no, and we want to change interest rates and number of payments per year, so check yes. Now you look up here and you see that the first payment excuse me, is April the 1st, and the next payment is July the 7th. July the 1st. In other words, it's changed now to every 3 months for these payments. And the interest rate has been changed to 6%. And that will continue, I think we said 2006. Here the payment was 1.5. I'm sorry, the annual interest rate. Apparently that interest rate did not change. Yes, it did. It changed. We just didn't hit it at the point. I forget it. I think it was 2006. There's 1.5. That's a change. It changed after 3 months. Go back to the top record. Now, this has an annuity feature. It evaluates the present value between taking a lump sum and a series of payments. Let's enter the lump sum, say $150,000. And the interest rate, we'll assume the interest rate is going to be 6%. Number of times per year the interest is compounded, 12. Total number of payments proposed, we'll say 120. The amount of each periodical payment, that we'll assume that it would be neighborhood of $5,000. I don't know what will result when we calculate. And it says that the compound rate at 6.17 rate you assume. This shows that taking the lump sum would be best by a huge amount. The present value of the series of equal payments at 6.1% is $81,004.81. But you would be better by taking the lump sum, best by this amount. This says that you, excluding the use of extremely variant entry values, which will produce an erroneous result, you can check to see what the break point would be between. So yes. The break-even interest rate would be 3.26%. That would you could take either the lump sum or the series of equal payments. this we can check the time lapse between payments. Let's check the time lapse between this first payment of April the 1st and October. There's an let's check this. This says to find the lapse time, highlight the earlier name, pay date in the list box that contains the asset symbol. Double click the name and double click the pay date. Next, highlight but don't click the later name and pay date in the list box. The difference is 762 days. This, at one time I thought about connecting this program to the internet for trading stocks, and so to pay no attention to this. This just says the proposed sale date is more than 60 days later than the buy date, so you should be okay, but check for gain or loss position consequences. Just pay no attention to that. And then you can sum two accounts the same way. Let's sum the account between April and October. Same message. Let's do that. Again, let's go between October 2001 and that. So left double click that, double click that name, and then highlight the next date, and then double click sum. That's the difference in the payment values. The payment number 3 was on 10/1 was 212,000, and on April the 1st it was 203,000. So that's could be a useful. Let's that's about all we need to talk about, I guess. But this sum payments. List of added payments that shows you that we added a payment on payment number 49 on 15th of the month of 2008. It was minus $10,000. And then it sums these payments, the rest of these payments. It's, since we had variable payments between that we added instead of the regular monthly payments, this total of all payments is correct, but this difference may not be exact. This is really designed for where you don't put variable payments, yearly payments included. If we don't have time to check to analyze what this means exactly. You can print the form and you can delete records, and we we mentioned we showed this utility. You can find a record name, go to the top record, bottom record, and you can change the number of lines of hard printout, hard copy, or the number of lines on the screen, and you can find account names. I think this is about all we need to show about this. But I appreciate you watching this. I know that I should have rehearsed this better, but nevertheless, we'll take it as it is. Thanks.